Hello guys, and welcome once more to this new video on my YouTube channel, where actually we are going to be solving a Cameroon GC examination pure mathematics with mechanics paper 3 question 2. So the question is divided into two parts, that is question 2 Romance 1 and question 2 Romance 2 actually. Question 2 Romance 1 with a body P of mass 10 kilograms lying on a smooth plane inclined at 30 degrees to the horizontal is connected to another body Q of mass 20 kg by a line in a tensible string which passes over a fixed smooth pulley at the top of the plane. The system is released from rest when Q is hanging vertically. Given that the coefficient of friction between P and the plane is 2 divided by 5, find A, the acceleration of P, B, the tension in the string, C, the magnitude of the force exerted by the string on the pulley, and question 2 Romance 2 rates. A particle moves in a circle of radius 2 meters with an acceleration of 8 pi squared divided by 81 meters per second squared. Find its angular displacement in 3 seconds. Let us then actually move into the solution of this question. In the first place, we are going to start by solving question 2 Romance 1 actually. So the first thing which you have to do is actually to come out with a figure which represents the scenario of actually what is happening. Of course, we are being told that we have two bodies, that is body P and body Q actually. Body P is actually on the inclined plane and the plane is actually inclined at an angle of 30 degrees. And of course, Q hanging vertically as such. The next thing which you have to represent is a corresponding weight. That is the weight of particle P is 10g and that of Q is actually going to be 20g actually, because we are giving their masses. That is the mass of body P is 10 kg and the mass of body Q is actually 20 kg. And G here is actually the acceleration due to gravity, which is given to be 10 meters per second squared in the equation. Yes, so these are the corresponding weights actually. The next thing which we are going to represent actually the acceleration. Let us consider our acceleration to be moving downward in this situation. In this case, that actually yes. So if our acceleration is pointing downward, it means actually the system is going to be moving in a clockwise direction. That is in a clockwise motion actually. Yes. So representing that, it means since our system is already in motion actually, it implies we have to represent the tension, that is particle P and particle Q exert tension which are directed towards the pulley actually, which is given to be T actually. These tensions are actually the same, reason why I included the same T here actually. Yes. The next thing which you have to represent is actually the opposite forces, okay, the forces which are acting opposite to the motion of body P actually, which are actually what? 10g sine 30 degrees and actually F, the frictional force here. Why have I included the frictional force? I've included the frictional force because in the last sentence of the question we have been told that the coefficient of friction between body P and the plane is actually 2 feet. Reason why we have to include that frictional force there, because the coefficient of friction between body P and the plane is given actually. Yes. So the next thing we have to represent actually the vertical forces which are acting on body P, which is R and 10g cos 30 degrees actually. Yes. The other of the question is asking us to get the acceleration of P. How then can we obtain the acceleration of P actually? In order for us to obtain the acceleration of P, we are going to form two equations. That is, we are going to apply Newton's second law on body P and Newton's second law of body Q actually. We are going to obtain two equations. From those two equations, we then solve those two equations simultaneously, and from there we are going to be able to obtain therefore the acceleration of P actually. In the first place, let us first of all apply Newton's second law on P. Applying Newton's second law on P, we have actually that we are going to have T minus 10g sine 30 minus F to be equals to 10 times the acceleration actually. We have simply applied Newton's second law on P actually. Because why is it T minus 10g sine theta minus F? Because our system is moving in a clockwise direction. That is the clockwise direction, that is it's going to be this tension minus the downward forces actually, that is 10g sine 30 minus F to be equals to the mass of P, which is 10 times the acceleration, which is actually A, what is being asked in the question actually. But we know that what, let us call it our equation 1 first of all, to avoid confusions actually when we are going to be manipulating actually the values. We know that what F is equal to mu times R, that is the frictional force equals to the coefficient of friction times this reaction force here, R here actually. But we don't have R. How can we get R? By simply resolving the vertical forces acting on P. So resolving the vertical forces acting on P, we are going to have that R minus 10g cos 30 degrees is going to be equal to 0, which actually implies that R is going to be 10g cos 30 degrees. from which we can therefore replace the value of R here. Actually, that is, the frictional force is going to be mu, okay, times 10G cos 30 degrees. Now replacing, that is substituting the value of F into equation 1 here. That is what was lacking. That's the reason why we first of all obtained the value of the frictional force and once we have the value of the frictional force, we can then come and replace it into our equation 1 actually. So substituting the value of F into equation 1, which already, that is the frictional force, which is mu 10G cos theta, into equation 1. We are going to have actually that T minus 10G sin 30 minus F which is what, mu times 10 times G times cos 30 degrees to be 10 times A actually. Yes, but actually we know that what G is actually 10, okay, and G is actually 10 and mu is actually 2 feet actually, and we know that cos 30 is square root of 3 divided by 2 actually. So you are simply substituted back the values of G, the value of mu, and the value of cos theta, which is actually the square root of 3 divided by 2 actually. Yes, so further simplifying, we are going to obtain that T minus 100, because 10 times 10 gives us 100, times sin 30 times sin 30 is just a half, minus 2 feet times 100, okay, find the square root of 3 divided by 2 to be equals to 10 times the acceleration actually. Further simplifying, you are going to obtain T minus 50 minus 20 square root of 3 to be equals to 10 times the acceleration actually. Let us then call this our equation 2 actually. So this actually the equation which, the final equation which we obtain when we simply apply Newton's second law on P actually. Doing same, that is applying Newton's second law on Q, what do we have? We are going to have 20G minus T minus the tension, okay, to be equals to 20, which is the mass of Q, times the acceleration. That is 20 times G minus the tension to be equals to 20 times the acceleration actually. Yes, for us simplifying, we are going to obtain 20 times G which is 10 minus the tension to be equals to 20 times the acceleration. For us simplifying, we are going to obtain 200, okay, minus the tension to be equals to 20 times the acceleration. Let us call this actually our equation 3. We already have this our equation 2 and our equation 3. As I told you in the beginning, once we are going to obtain these two equations, we are simply going to solve them simultaneously actually. And how then can we solve them simultaneously in order for us to obtain the value of A actually? So you can simply add equation 2 and equation 3 actually. So that is equation 1 plus equation 3. Adding equation 2 plus equation 3, what are we going to have? We are going to have actually that T minus 50, okay, minus 20 root of 3 is equals to 10 times the acceleration. That was our equation 2. Then plus 200 minus the tension to be equals to 20 times the acceleration. So this we are doing this because we want to cancel actually this tension, because once we are going to add these two equations, we are going to clearly see that the tensions are going to cancel actually. Yes, so doing that, we are going to obtain 150 minus 20 times the square root of 3 minus to be equals to 30 times the acceleration. Once you can simplify furthermore and obtain the value of A to be therefore 3.85 meters per second squared, which is actually the acceleration which was asked, okay, for us to determine. That is the acceleration of P. And remember, it is the same acceleration that Q has actually. That is this 3.85 meters per second squared. It is the same acceleration with which particle Q is also moving. That is in this motion actually. Yes. The part of the question is asking us to get the tension in the stream. So to simply get the tension in the stream, what are we going to do? For the tension, substituting A into any of the equation, that we can substitute A into equation 2 or equation 3. But let us substitute, okay, the value of A into equation 3 actually. Substituting the value of A into equation 3 actually, we are going to get 200 minus the tension, okay, to be equals to 20 times the acceleration actually. That is 200 minus the tension to be 20 times the acceleration. We know that the acceleration is actually 3.85 meters per second squared actually. Further simplifying, we are going to obtain the tension to be equal to 123 newtons actually, which was actually the tension, okay, in the string actually. Yes. The C part actually is asking us to get the magnitude of the force, okay, exerted by the string on the pulley actually. Here actually you have to take note, okay, of the fact that in order for us to get the magnitude of the force exerted by the string on the pulley, you have to come out first of all with this small figure to actually see what is actually happening. This, okay, figure which we have presented is what is actually happening at the edge here, that is here actually. That is at the edge here, the angle is actually 60 degrees. Why? Because here you have 30 degrees. You know that 30 degrees plus, okay, this 60 degrees is up 90 degrees, so it is valid. Okay, yes. So here we have 60 degrees actually. Yes. So You have to know that since the angle between the tensions, okay, at the pulley is 60 degrees, the reaction bisects this angle. As I told you, here we have an angle of 60 degrees, and since the angle between the tensions and the pulley, which is 60 degrees, is 60 degrees actually, therefore the reaction, okay, bisects this angle actually. Yes. Similarly, each tension has a component of T equals 30 degrees, okay, along the line of action of the reaction force. That is, each tension, that is this one and this one, okay, they both have a component of T equals 30 degrees along the line of action of the reaction force actually. Yes. If I put it later, hence the reaction force is actually going to be equals to F, which is equals to 2 times the tension times cos 30 degrees actually. You know that actually the tension is what, 123 actually. So between the value of tension here, we are going to obtain F to be equals to 2 times 123 times cos 30 degrees actually. Yes. From which we are going to obtain therefore the value of F, that is the force exerted by the string on the pulley, to be equals to 213.04 Newton actually, which is actually the magnitude of the force exerted by the string actually on the pulley actually. Yes. Actually, let us therefore move into the Romans 2 actually, that is question 2 Romans 2. Question 2 Romans 2, with a particles move in a circle of radius 2 meters with an acceleration of 8 pi squared divided by 81 meters per second squared. Find its angular displacement in 3 seconds actually. In order for us to get this one, we need something very pertinent, that is an equation, okay, that is, we are going to express simply Newton's laws of motion, okay, in terms of angular motion actually. Yes, that is representing this formula, that is d theta equals omega t plus half alpha t squared, is actually Newton's law of motion, but this d theta is actually the angular displacement, omega is the angular velocity, alpha is actually the angular acceleration actually here actually. And what is being asked in this question, you are being asked to find the angular displacement, that is d theta. And we know that since the particle, okay, was moving, okay, in a circle, it means initially, okay, that angle was 0 actually. Yes, so d theta is actually going to be the final angle minus initial angle, and the initial angle is 0. So I can simply write this equation back to be equals actually theta equals omega t plus half alpha t squared, where theta is actually what is being asked in this question. Omega is the angular, okay, velocity, and alpha is the angular acceleration actually. Yes, so this is what we are looking for here, but we don't have omega, which is the angular velocity. We don't have alpha actually, but we can determine, okay, both of them. Let us first of all determine omega actually. We know that actually the acceleration, okay, that is the linear acceleration, is equals to omega squared r, from which you can therefore come out with omega to be equal to the square root of a divided by r actually. Yes, from which we can therefore substitute the value of a and r, that is omega is going to be equal to the square root of 8 pi squared divided by 81 times 2 actually, which therefore gives us omega to be equal to 0.698 radian per second actually. Yes, we have already obtained omega. Let us now obtain alpha actually. We know that also as well that the linear acceleration expressed in terms of angular acceleration is actually a, which is the linear acceleration, to be equal to alpha r, where alpha actually is the angular acceleration. And this is what we are trying to look for in order for us to come and substitute here and get the value actually of the angular displacement. So from this equation you can clearly see that alpha is going to be equal to a divided by r, where a actually is the linear acceleration, okay, then divided by the radius. Doing that, we are going to obtain 8 pi squared divided by 81 times 2, which therefore gives us alpha, which is the angular acceleration, to be equal to 0.49 radian per second squared actually. Therefore, substitute this value of alpha and omega, we are then going to obtain actually our angular displacement, okay, in 3 seconds. Substituting those values, that is the value of omega, which is 0.698 times the time which is actually 3 seconds, plus a half times alpha, which is actually 0.49, then times the time which is 3 squared actually, on which we are going to obtain therefore that theta, which is the angular displacement, is going to be actually 4.0 radian actually. Yes, so this is actually the angular displacement which was asked actually in this question actually. Yes. So thank you very much for watching this video, and remain tuned, okay, for a very next interesting video concerning mechanics. And please you just don't forget to like, subscribe, share, okay, for the YouTube channel to grow actually, and see you then for a next interesting video concerning mechanics. Thank you.